What if the sun was smaller than Earth? Imagine waking up one morning to find that the sun, our blazing, life-giving giant, has shrunk to the size of a soccer ball, just floating up there like a lonely balloon. No more warm sunlight on your skin, no sunrises, no sunsets, just a faint, cold glow barely hanging in the sky. Sounds like science fiction? Absolutely. But it's also a mind-bending scientific thought experiment, one that reveals just how fragile and precise the balance of our solar system really is. The sun isn't just a big flashlight in the sky. It's a nuclear powerhouse that anchors our entire existence. But what if it lost its cosmic muscles and became smaller than Earth? Could life survive? Would Earth stay in orbit? Or would everything, literally everything, fall apart? Buckle up, because this is where science gets chilling, fascinating, and a little bit terrifying, all at once. Let's start with the obvious. Our sun is a star, not just a big fireball in the sky. It's a cosmic engine powered by a phenomenal process called nuclear fusion. Deep inside its core, temperatures reach over 27 million degrees Fahrenheit. Under that unimaginable heat and pressure, hydrogen atoms are slammed together to form helium. The sun isn't just a big flashlight in the sky. It's a nuclear powerhouse that anchors our entire existence. But what if it lost its cosmic muscles and became smaller than Earth? Could life survive? Would Earth stay in orbit? Or would everything, literally everything, fall apart? Buckle up, because this is where science gets chilling, fascinating, and a little bit terrifying, all at once. Let's start with the obvious. Our sun is a star, not just a big fireball in the sky. It's a cosmic engine powered by a phenomenal process called nuclear fusion. Deep inside its core, temperatures reach over 27 million degrees Fahrenheit. Under that unimaginable heat and pressure, hydrogen atoms are slammed together to form helium. That process releases an enormous amount of energy, which travels outward through the sun's layers and eventually escapes into space as the sunlight and warmth we rely on every day. So, why does that matter? Because nuclear fusion doesn't come cheap. You need serious mass, gravity strong enough to crush those hydrogen atoms together. That's the sun's job. With a mass about 330,000 times greater than Earth, the sun has no problem handling fusion. It's been doing it non-stop for about 4.6 billion years. But now imagine we shrink the sun down, way down, until it's smaller than Earth. What happens? Fusion shuts down. Period. With too little mass, gravity can't create the pressure needed to trigger fusion. The sun wouldn't be able to ignite, and without that nuclear engine, it would go dark. No fusion means no heat. No heat means no light. And no light or heat means, well, no life. The sun wouldn't be a star anymore. It would just be a cold, dim sphere of gas floating in space, the cosmic equivalent of a car that never got its engine. Scientists even have a name for these underachievers: brown dwarfs. They're what you get when a star doesn't quite make the cut. Too massive to be a planet, too small to burn like a true star, just sort of hanging out in the galaxy, glowing faintly in the infrared, forever waiting to shine, but never quite making it. If our sun had turned out that way, the entire solar system, assuming it formed at all, would have been built around a dud. No warmth, no seasons, no sunsets. Earth, if it existed, would be a frozen world orbiting a star that never turned on the lights. And here's the kicker. Without sunlight, photosynthesis wouldn't happen, which means plants wouldn't exist. And neither would the oxygen-breathing creatures that depend on them. In fact, nothing we currently know as life could survive in such a universe. So, to put it simply, if the sun were smaller than Earth, it wouldn't just be smaller. It would fail at being a star. And that failure would ripple across everything, erasing the most basic conditions life depends on. The sun isn't just a pretty sky decoration, it's the beating heart of our solar system. Without it, the story of Earth wouldn't just change. It might not exist at all. Picture this: the solar system as a perfectly choreographed cosmic dance. At the center is the sun, a massive gravitational heavyweight pulling every planet into place like an invisible conductor. Mercury sprints in tight circles, Neptune cruises on the outskirts, and Earth pirouettes in the sweet spot that makes life possible. It's not chaos. It's celestial harmony, and that harmony, it exists for one reason: gravity. Not just any gravity, the gravity of a sun that's 330,000 times more massive than Earth. That incredible pull keeps all 8 planets, dozens of moons, and millions of asteroids locked into orbit, looping endlessly around our star like loyal satellites. But what if the sun suddenly shrank to something smaller than Earth? Cue disaster. A sun with so little mass wouldn't have the gravitational muscle to keep anything close. Its pull would weaken to the point of irrelevance, like a magnet trying to tug on a refrigerator from across the street. The planets would no longer feel the sun's presence, and without that gravitational anchor, they'd drift away into the cosmic void. Mercury would shoot off like a rogue pinball. Mars would lose its red glow to the cold of space. Jupiter, the gas giant that helps stabilize the inner planets, would become a homeless wanderer. And Earth? Our home would go from a planet in orbit to a rogue world, silently sliding into the abyss. The solar system as we know it would cease to exist. Instead of a unified system with orbits, structure, and rhythm, we'd be left with a scattered mess of planets and space rocks, each fending for itself in the cold black. You could call it the solar scatter. Poetic? Maybe. Stable? Definitely not. This wouldn't just be an existential issue for astronomy textbooks. It would end everything that depends on stable orbits. Earth's year? Gone. Our seasons? Erased. Day and night? Good luck figuring that out while tumbling through the darkness. Worse still, a drifting Earth might stumble into danger. A random asteroid belt, a deadly gamma-ray burst, or, if we're really unlucky, the gravity well of a black hole. And no, you can't just turn around in space. Once you're unanchored, you're at the mercy of the universe. So, while it's fun to imagine a tiny, pocket-sized sun, the reality is chilling, literally and figuratively. Without its gravity, the sun can't hold the family together. The planets scatter, the dance ends, and Earth begins a journey no one bought a ticket for. So now, Earth is no longer anchored to the sun. It's adrift, alone, and, worst of all, unheated. And that's when things really start to go downhill. Fast. Without the sun's warmth, our planet turns from a cozy cosmic condo into a sub-zero nightmare. In just 1 week, the average surface temperature would plunge below 100 degrees, 73 degrees. That's colder than the coldest places on Earth today, and you wouldn't even need to wait for winter. Pipes would freeze, lakes would crust over, cars? Forget it. Not even a flamethrower could warm your windshield. But give it a year, and things get downright Pluto-esque. We're talking 330 degrees, 200 degrees, colder than liquid nitrogen, colder than any natural temperature ever recorded on Earth. The oceans? Solid. The rivers? Gone. Rain? More like falling shards of ice, assuming there's still an atmosphere left to let anything fall at all. Speaking of the atmosphere, it wouldn't stick around for long. As temperatures drop, gases like nitrogen and oxygen, the very stuff we breathe, would condense and liquefy, eventually freezing solid. What was once air becomes frosted layers of frozen gases, coating the planet like some twisted dessert no one asked for. No more clouds, no more sky, no more breathable air. All that's left is a dark frozen marble tumbling through the galaxy. A wandering planet, eerily silent, completely lifeless, and utterly unreachable. Think Hoth from Star Wars, but without the rebels or even a tauntaun to ride. Just mile-deep ice and a cold that cuts deeper than any sci-fi scene can capture. And the worst part? There's no reset button. Once Earth slips into this cosmic cryosleep, nothing, no fire, no technology, no miracle greenhouse, can bring back the warmth we once took for granted. This is what happens when the sun, quite literally, leaves the chat. Let's rewind the cosmic clock a bit. Up until now, we've been assuming Earth exists, frozen, drifting, doomed, all because the sun shrank. But what if the sun never had a chance to shine in the first place? Stars don't just show up out of nowhere. They're born in massive clouds of dust and gas, called nebulae, which collapse under their own gravity. If enough mass gathers in the center, the pressure and heat ignite nuclear fusion, and boom, you've got a star. The leftover material flattens into a disk, forming planets, moons, asteroids, and other space debris. That's how we got our solar system. But if the central mass, our wannabe sun, never reaches the fusion threshold, then we don't get a star. We don't get a stable disk. And we almost certainly don't get planets like Earth. Instead, we're left with an awkward mess of gas and dust just kind of hanging around, uncoordinated and unstructured. Maybe a few random clumps turn into planet-like objects, but without a central gravitational boss to keep everything in line. These worlds would be scattered and unstable, cosmic orphans with no parent star to guide them. So, no sun? Probably no Earth, which means no oceans, no trees, no Jurassic Park reboots, and yes, no TikTok. Just an empty corner of the galaxy where a planetary system almost happened, but fizzled out before the opening credits rolled. This isn't just a hypothetical twist. Astronomers have spotted actual failed systems. Starless regions with drifting gas and half-baked planets, proof that not every solar system makes it to opening night. We lucked out. Final thoughts. The sun is no joke. We joke about the sun, complain when it's too hot, hide from its UV rays, wish for clouds when it's blinding through the windshield. But make no mistake, the sun isn't just another star in the sky. It's the heartbeat of our entire existence. It controls our seasons, sets our clocks, powers photosynthesis, drives ocean currents, and literally holds the solar system together with its gravity. Take it away, and we don't just lose daylight, we lose everything. So next time you're lounging at the beach, or even sweating in a summer traffic jam, maybe give the sun a little credit. Without it, Earth might not just be colder or darker, it might not exist at all. Because when it comes to life, balance is everything. And in the great cosmic recipe, a star just big enough to burn, but not too big to explode, is the one perfect ingredient that lets us call this pale blue dot our home. So now that you've traveled through a frozen Earth, a failed sun, and a solar system gone wild, what do you think? Could you survive in a starless universe? Or are you suddenly feeling a little more grateful for that morning sunshine? Drop your thoughts in the comments. We'd love to hear how this cosmic what-if hit you. And hey, if you enjoyed the ride, don't forget to like, share, and subscribe for more mind-bending science with just the right amount of existential crisis.